Thank you everyone for joining us today on a webinar which is part of the, it's called Data Innovation in Official Statistics and is part of the Road to Bern. I'm Ronald Jensen. I'm with the United Nations Statistics Division in New York. I'm very happy to have everyone here today. The webinar is organized in one sense as a lead up to the UN World Data Forum, which is next week. It was originally planned to be in Bern, and it will still happen physically in Bern next year. And in the coming week, it will be a virtual World Data Forum, but still under the heading A Road to Bern. The webinar is an initiative of the UN Global Working Group on Big Data. This is a collaboration of national statistical offices, or in general the community of official statistics, and this group specifically looks at how new data sources, new technologies can be used for official purposes. Before we start, a few words. We'll try to keep all the microphones muted. My colleagues will turn them off, but hope that everyone can mute it. If you have questions, please put the questions in the chat. You see a chat icon at the top. Please put questions you have in the chat box, and we will try to address them at the question and answer sections of the webinar. We'll do that after each presentation. Also, for you to note, we are recording the webinar with agreement from our presenters, so that also later on we can post this for viewing by those who could not make it today. Let me give you an overview of the program. So just what we are trying to do today, there's a very short overview of what the Global Working Group is doing, just to get a frame in which we are working. Then I'm very happy to have Bertrand Loison, the Vice Director of the Federal Statistical Office of Switzerland, who will give an overview of the Data Science Competence Center, a new initiative of the Statistical Office of Switzerland. So very happy that he will introduce that. And then after that, we have presentations of two groups. They were teams competing in the recent hackathon on the use on AIS data. And these group will show what they have done during that hackathon. Very happy to be able to present that kind of innovative work. I will introduce the Blue Carbon team and the Data Caliber group a little bit later in the program. Very happy that they will be here, and I think it's very exciting the kind of work that they will show. So for a starter, I will then go to my own presentation. So I find it here. Let me see if I get the right one here. So I will give a little bit a short overview of the work of the UN Global Working Group on Big Data. Let me see again. Sorry for that. It takes a little bit of time to get the right screen up. There are also still people coming in, which is good. Okay. So a short introduction on the work of the UN Global on the global working group, and specifically also on the global platform that we are using. And I hope I have the right presentation up here. Yes. Sorry. So, can you hear me? Oops. So the UN Global Working Group consists of, as I mentioned, experts from national statistical offices and working together on how to use several kinds of big data for official purposes. The work is driven, as you can see. I don't know how well you can read this, but in the blue boxes here, there are a variety of data sources and topics on which this group of experts working. Some of them are not. I will show you a few of that in this presentation, specifically also on the AIS data, as this is coming back in this webinar. So the kind of teams which are working on the global working group, I'll give you a few of them. We have a task team that works on the use of Earth observation. The task team on Earth observation, it has it prepares guidance on how we could use the satellite data. They prepare the handbook, and they also prepare training materials. We like to build capacity in the statistical offices, so they can use this. There are also some project work going on. We are looking at a project to use satellite data for agricultural statistics, and we're also looking at a project which we will put on our collaborative environment. We have one collaborative environment for this global working group. It's called the UN Global Platform. It's a cloud-based environment, and we're also trying to build their measurement of ecosystems. That's where this group is working on. We have a group that works on mobile phone data. And that's I hope you can still see my screen, because okay. So we have a group that works on mobile phone data. They're looking at methodologies to apply the use of mobile phone data in a variety of ways: tourism statistics, dynamic population, and others. They've also been very active. Members of this group have been very active in getting indicators to look at human mobility around the COVID-19 pandemic. We have groups like Flowminder and others who are working with us. On the AIS data, there's a group that works on it, a very active group, and that's also where we are focusing on during this webinar. They provide guidance on one hand about what AIS data is, how we can use it. They have training materials. They also have an application which is currently available on the website of the Global Working Group, which generates or which gives port calls, so ships coming in and out of ports around the world. It's updated on a weekly basis, and you can see this over the developments over the last 2 years, but specifically, of course, over what's happening over the last a year or so, and how COVID-19 has affected the number of ships coming in and out of port. So in principle, the trade, how that has been influenced by the pandemic, that can be monitored through this application. We've done the AIS Hackathon. We come back to that during this webinar. There was also an online training course which is being prepared. If I look at, so the next one is on the some information about the automatic identification system, the AIS. This is information which is transmitted by ships on their location. It's initially also done for safety purposes. we're using this to do for other purposes. Just 2 words on this, and our teams that will present will go into the details of how it can be used. But what is AIS data? If I go to the next slide here, so there is part of it is dynamic information. So it gives the navigation status of the ship. Once the ship is in movement, it's transmitted every 2 to 10 seconds, depending on the speed. If it is anchored, it's transmitted every 6 minutes. There are some other elements here on the ground speed and so forth. There's also a part of it which is static information, which is transmitted every 6 minutes. It's about the kind of ship, and also the volume of the load of the ship is also basic information in there. We have under the Global Working Group also a task team on training, because training is very important for the kind of work that we do. We like to build capabilities. This again within the national statistical offices in the first place, so that they will have their own capacities to be able to work with new data sources and new technologies. And we're trying to build this through a global program on training over the next couple of years specifically. There are a lot of other institutes working with us. It's not only national statistical institutes. We need to work with academics, private sector, and others, because specifically in this field, there is a lot of additional knowledge and expertise that we would, what our community would like to build on from expertise from other communities. A little bit about the UN Global Platform. It is a cloud-based platform, so you can access it from many places, from anywhere. We have a number of data sources on this platform. The AIS data, as I mentioned, we have some access to some satellite data, to some scanner data. We have services which facilitates the way in which we can work with those data. And then there are some support services in which we monitor the performance of the platform. There are a number of projects which are currently running, also to indicate here that we're the kind of projects that we do, we specifically also like to see that we're having a number of institutes from developing countries that can use that, like the satellite data for crop statistics. We're trying to see if we can use this in Senegal and Uganda in the pilot phase, and then build it out to other countries after that. We have some facilities also for data dissemination, state of the art. We've done that in Cambodia currently. We're trying to see if we can do that in other countries, and so forth. So I'll stop here as an introduction to this work of the Global Working Group, and I will then now move to the first presentation. I'll see if I can go out here out of my we go to the presentation of Bertrand Loison. Bertrand is, as I mentioned, the Vice Director of the Federal Statistical Office of Switzerland. Bertrand is also a part of the Global Working Group. We're very happy that he will be able to do this presentation today. He's been a member of this group, and he is also a professor in Switzerland. And I forgot the exact university at which you work, Bertrand, but I will leave that to you, and I'll give the floor to you right now. Please go ahead.
Okay. Thank you very much, Ronald. I'm professor at the University of Applied Science, Western Switzerland, but it's not the main purpose of my presentation. I hope you can see my presentation. And yeah, thank you, Ronald, and all the members of the UN Global Working Group for giving me the opportunity to present a little bit what we are currently doing in Switzerland regarding a new data science competence center. And I will spend the next 20 minutes trying to explain a little bit where we are coming from and where we are going. And the key idea of this data science competence center is really to be a competence center for the whole federal administration. I divided my presentation in 5 points, if you want. I will start with the historical context. As Ronald mentioned that a little bit, we started many years ago, and that's a little bit a timeline about data innovation in Switzerland, especially in our NSI. We started, we can divide our work in 3 phases. The first phase was really an exploration, and the key idea was really to identify if it's worth it to invest in big data and data science. I will speak a little bit more about that later. The second phase was to write some concepts, but first of all, to have the proof of concept that it's really worth it to invest money and resources in this field. And the last one is that this is the institutionalization from this data science competence center. And how we did it, we started, so the initial input, if you want, came from the UNSD. I have to say, because that was mentioned in the report, the minutes of a meeting, that we need to investigate a little bit in big data because it could have a big impact of national about NSI. And we created a working group inside FSO that really take time to identify, is that a hype or not, and what could be the consequences. It took more or less 2 years. After that, we decided to take that more seriously, and we published in 2017, the data innovation strategy with a clear focus on methods, statistical methods, deep learning methods, machine learning, because I was pretty convinced that it's the hard part of the game. That's the tricky part. We also started 5 pilot projects with a clear goal to prove that that official statisticians can really have a real benefit of these new methods. And we also started a new ad hoc data science lab. We published our result for this 5 pilot projects at the end of 2019 in the press release. And after that, we were facing really a key question. And the question was, do we really need to do that for ourselves, or should we try to establish a data science competence center at the federal level? And we decided to do that, and we wrote a paper, and we addressed this paper to the Federal Council, which is the highest political level that you can find in Switzerland. And the Federal Council decided in May 2020 to give us the go to create this data science competence center. That's a little bit the story behind the scene, what you probably don't know, and you can't know if you are not an insider. But I found now quite important to explain that. Now, okay. Maybe briefly, I will explain the mandate that we got for the Federal Council, that you can have an idea. And after that, I will try to answer probably something that could be useful for you. Is why a data science competitor in an NSA at the FSO in Switzerland. Okay, the mandate that we received is to create a center of excellence for data science, and we have to start the 1st January 2021. And the key idea is to offer services in the field of data science, not just for our office, but for all federal agencies, and to promote knowledge inside this federal administration. This is the first thing. The second thing is that we have to do during the first 6 months of 2021 is to propose a governance. I will speak a little bit more about that later. It seems to be very easy, but when you establish such a competence center, you need to be very careful about the governance of this competence center. And at the end of the day, we will have also to prove that this competence center is really a benefit for the whole federal administration, which means we will have to prove with a cost-benefit ratio up to the end of March 2024 that this competence center was really a good idea. That's the mandate that we got. And now maybe something I felt quite important for you, maybe to hear what arguments that we used in order to convince other federal agencies, but also the Federal Council to put these, to give the responsibility to the FSO and not to another federal agency. The first one was why? Because analytics, which means the learning from the data, is our core business. And it was quite important to describe that we are currently very strongly focused on descriptive statistics, but we will also have to move step by step to diagnostic, predictive, and prescriptive statistics. At the same time, it was also very important to explain that this paradigm that we know as official statisticians is a search for causality. We will have to question that and to try to do the best with these new data, these new methods, and this search for causality that is quite important for us as official statisticians. That was the first argument, to say we know how we can generate insights from data. The second argument that we use is that FSO has an interest itself to be up to date with this question of big data and data science. Here, that's a slide from the IMF, but I think this slide is very good because it shows very clearly the potential of big data, also for official statisticians. So we were really convinced that we can have a benefit as official statisticians to use that. It was not so clear for every, and also to say to all federal agencies, but they were quite convinced that it's our own interest to move forward in these topics. It's not just a new task, it's our core business in the future. The next thing that we use is the work that has been initiated by the UNSD, and in my eyes, a very good work. I'm talking about the UN Global Working Group. We could prove that official statisticians know about what they are talking about when they talk about big data, that we have a community and we have also a marketplace. And I think it was quite important also for the other agency that have other mission to see that we are able to deal with all this kind of data, and we are also thinking about capacity building, what Ronald mentioned before. And we needed also, and maybe that's something that was quite complicated to explain, was a necessity to really to prove by the fact that we are able to run and conduct projects, which means with these new methods, deep learning, machine learning, and we started the 5 projects that I mentioned before. We published the results and they are publicly available, the results and the reports. And that was also a strong argument. And something that the next one is the code of practice. Don't underestimate the power of this code of practice. I mean the the rules that we have to respect, these principles that we have to respect, and I was surprised that it has really great understanding at the political level that we have to respect that, which means especially the confidentiality of statistics, the data protection, also the methodology itself, and the transparency that we have to publish our methods. It was quite also a strong argument. And the last one, it's a new one. You will see at the end of the presentation, FSO has two new roles, gained two new roles this year and last year. The first was in 2019, and we got the task to, and we are responsible to establish a national data management program and an interoperability platform. The key idea is that FSO will be is responsible for the interoperability platform, and the goal of this platform is really to make a link about metadata with other federal agencies, with cantons, with communes, with companies, and with the academics. And we also the Swiss data steward, if you want. And it was quite interesting also to explain that that we can add value to this interoperability platform if we are also able to generate insight with data science. Okay, that was the argument. I hope it will. It has been quite interesting for you to hear the arguments. And now the services, which kind of services we will offer. Before I speak about services, I would like to speak about our vision of this data science competence center. As our key purpose is we use data science and develop skills for public good in Switzerland. We are, which means not just at the federal level, but also at the cantons level and communal level. We have the intention to work at the crossroad between data science and artificial intelligence, which means we have to build skills and method techniques and practice to obtain these evidence-based decision making for public good. That's a mission, and our idea is to offer data science as a service with four main pillars. The first one is the consulting, the second one is methodological support, the third is project management, and the fourth is training, and we have also a core service. I will explain that now. Also, data science as a service, the key idea is to say, okay, if a federal agency needs to have some, have a need to, I don't know, regarding education, for example, it can pick up this service, education, and only this one. That's really a service that we offer. We have also a portfolio of services, a service portfolio, and you can pick up as an agency what you need, what you want. That's the key idea. I have also to mention that we will have to cover all costs, and which is quite challenging. The next services that we will offer is the consulting. Here it's much more for the CEO of the federal agency. We will offer consulting regarding strategic, tactical, and operational applications. Very often is what we saw is that federal agencies are not really aware about the potential of artificial intelligence, deep learning, machine learning. They don't really understand what is the potential, and we are really convinced that we can offer very good advice in this field. The second one, which is quite tricky, is the methodological support, and we will offer on-the-job training in this field to other agencies if required. For this agency, we have I will present at the end the organization, but we have the skills and the knowledge inside our NSI. what the next service is a project management here. We have some federal agencies, they are very small, and they don't have the people, the skills to run such kind of projects with data science, and we have to take that, so we will offer to take that we will take the responsibility for that. The next one is the training. That will be more off-the-job training. We are not concurrencing the private sector. It was also a very clear goal from the Federal Council. It's not allowed to, to be in competition with the private sector. We will do a very dedicated and specific training about that. And at the end, we will also offer some basic services regarding the statistical background that we have, and also what is the quality standard, the guidelines. We also have to develop and to increase our guidelines for data protection in Switzerland, basic infrastructure, sandbox, and so on. Well, that's more or less the portfolio. The core values are very close to statistic, as you can see. Information security, data protection, data security, and so on. And for example, the key idea is as if another federal agency would like to use this new method, we will also publish not just the results, but also the method that they use, the data, in order to be very transparent. We will, of course, respect the data protection, but it's the idea. Of course, we can't do that alone, and we establish a strong cooperation with many institutions. That's really a cornerstone of our competence center. With academics, we currently have an agreement, or we are trying to, we are finishing to sign an agreement with the best university, one of the best universities in Switzerland, and also with some IT providers inside the federal administration and outside the federal administration. It takes a lot of time to do that, I also to say, but we have to do that. It's very clear that we can ensure everything on alone. We need to establish this partnership with academics, with university, with research institute, and so on. Voilà. And now the next step, our office will change quite massively in January 2021. As you can see, from the historical point of view, we had FSO was had one pillar, if you want, that was the statistic production with based on register or surveys, the classical one, if you want. And we got two new roles. The first one is the data steward, and we create a new division. The name is interoperability and register division. We had the register division, of course, but we need to increase the scope of this division in order to be able to deal with this new role of Swiss data steward. And we also create a new division which is called Data Science Statistical Method Division with two main sections. One is the Statistical Method section, is still existing, and the new one with the name Data Science. I won't detail everything on these slides. I think maybe I thought it can be useful for you to see a little bit what we have to do in order to establish such a competence center. Believe me or not, my day are quite busy currently because I have to produce with my colleagues these documents. And the last slide that I would like to present is a little bit how we would like to scale. Also, the first at the beginning we will offer services for our NSI. After that, we will extend these services to all producers of official statistics, and the last phase will be to offer our services to the entire administration, which means quite a shift for us, because the purpose of this federal agency are administrative purpose and not statistical purposes. And the rest, I explained the rest just before. I'm finished. I don't know if you have questions regarding my presentation. But
Thank you very much, Bertrand. If I can start off the questioning, just for good understanding, Bertrand, I think it's very exciting that that the Statistical Office of Switzerland is starting to take on the data science as part of your work. The Data Science Competency Center. So I saw that you indicated your new division and the Data Science section. Is the Data Science Competency Center, is that a physical somewhere? Is it how does it link up with your Data Science section? And is it in terms of personnel who's actually working there? Do you get additional people just on the practical side, how that works, Bertrand?
Yeah. Also, question. The competence center is the division that I mentioned before. So the head of the division is the head of the competence center, data science competence center. We strongly believe that it's quite important to have in the same division the statistical method, the classical one, if you want, and also this section data science, which is much more oriented with these new methods, this inductive approach. And we got 10 people, we can hire 10 people in our office. They are physically located in our office, and we know that it's not sufficient to cover every demand that we will have, and that's the reason why we establish this partnership with universities, because we will have the possibility to work with professors inside the universities, but also with PhD students, master's students. That's the key idea that we have. And I mentioned that we need to cover the cost, which means that's not the service that so the federal agency that would like to have access to our services, we have to pay for that. Okay. And after that, it's really a question of are we able to motivate the other federal agencies to work with us, yes or no? And yeah, that's a little bit the business model behind that. Very simplified, but it's a business model. I don't know if I answered the question, but
yes, yeah, no, yeah, no, it's I see how you start out from the practical situation at the statistical office. You created a new division and you build it out from there. Also depending, I guess, on the demand that you will get and so forth.
So we would like to start small, you know, and to ensure the quality of the services. And if we are able to offer what the other federal agency want, I think we will grow naturally. But the key idea is not to start by hiring 40 people, because I think we are not able to manage that. We need to start small and to grow step by step.
Excellent. I would like to open the floor for questions. I did not see specific questions in the chat. So if somebody wants to ask a question, please raise your hand, and I will then we can then open the mic for you, or you can open your mic. But if you please raise a hand if you would like to ask specific question to Bertrand regarding the Data Science Competency Center that will be launched on the 1st of January. Any specific question here?
That means I was clear. No, I'm kidding.
Yes. Okay, I see two questions here. So I first give the floor to Ivo, and then I see Jakob. But first, Ivo, please go ahead.
No, thank you. Thank you, Bertrand. It is indeed very interesting to see these developments and see how you plan for it and then start to, program it in terms of making this a reality. So to understand all these different facets of creating a data center is important. As you know, there are other data centers coming up, and there are centers already in place at different NSOs. So in that context, that we see an understanding that when you want to really start to apply it, not through the national statistical system, but also for official statistical sort of purposes, then a center would, be very helpful in coordinating that approach. That's basically what we're saying, rather than having it scattered. So it is basically bringing that expertise together. And as you clearly indicate, you have to link up with the academic world, very much so. I think you said, although you were not very elaborate on it, what is the role of the private sector collaboration in this area? So is there something, you were very brief on this, you would basically say, well, we need technology, so something maybe I have to purchase cloud environment. That is one. So in that, let's say, national partnership that you started to unfold, right, in your presentation, you were mentioning that. So that's at the national level. But what is the potential to work much more internationally with those institutions that create, these data science campuses, centers, and can we benefit from that? I'm just raising it because my sentiment is that at least that will go to the Commission from the Friends of the Chair to actually create a network, right, among them, and just to get your sentiments about, whether that collaboration, even in the initial phases where you are, would be beneficial to learn from practices, data acquisition. I'm just taking a big one. Do we all start to now having our own cloud environment, technology sharing, data exchanges? So should we, in our conceptual development and in our sort of new institutional arrangement, start to think much more in a corporate way between the national statistical institutes? And would there be any appetite for in your context? Although I heard very much, everything has to grow very organically when we start small, but is an early on sort of network helpful for your considerations?
Yeah. Well, thank you very much for the question. Indeed, I forget to speak about our stakeholder management regarding businesses and enterprises, private sector. And currently, we had some contact with the private sector, and but we need to consider a little bit the purpose of this contact, and we established some contacts. We are not sure what is the right way, because we have also technical infrastructure inside our administration, and that's something that we need to clarify during the next months. If but I guess that could be quite a very interesting way to follow, because as the private sector has a lot of things to offer regarding that. The question is always a little bit the same. We are dealing with very sensible data, and the question is who will have access with the data, and we can jeopardize the trust that other federal agency have with NSI, as with our FSO, but we are investigating, and I guess we will establish some agreement in the future, but I'm not able now to exactly to give a name or something like that. That's an answer for the private sector. Then of course the other things is the cooperation at the international level. Yes, definitively. I am especially thinking with the colleagues from UK, and we'll have contact, because they are much more advanced as what we are, and also Netherlands. we will do that. But I have also to say the first things that we have to do is really to write this paper in order to get the mandate. And he spent really a lot of time doing that, convincing everyone. And now we have this mandate, and now we can start, and we will do it. And we will also be much more active with the UN Global Working Group, but it was the case until now. But I also to say, as I mentioned before, we spent a lot of time convincing all authorities as well as the other federal agencies that it's the right way to go. Definitely.
Thanks, Bertrand. Yeah, I think the big win is that you have made the first step, that you get the data science center, and then you start building from there.
Yeah.
Yes, and we'll look forward to that collaboration. One last question, and then we go on to the next presentation. Jakob, please.
Thank you very much. Very quickly. You said you'll start small, which is good. It's a good approach. But which statistical domains do you want to start with? Because this will really help other countries to take some experience as well. And if you identify those statistical for this approach, I mean, what was your criteria for selecting that one? That's one. Second thing you mentioned about partnership, which is, again, it's very important. I mean, it's we can't handle it by one institute, but how are you going to deal with the legal support? Because just partnership might not sustain the whole thing. Therefore, have you thought of how to really legally support this type of partnership? Thank you very much.
Yeah. So thank you for the two questions. I will start by trying to answer the second question regarding the partnerships. So the partnership will be established based on the contract with this entity. But I don't know if you address the point of the responsibility. That's regarding the result that this competence center will provide, and of course the responsibility for the results of what we publish or what other agencies are using is even if we have partnerships with academics, with private sector, we will take the responsibility for. We'll have to take the responsibility for the result, but the way we want to deal with that is with a contract. I don't see another option to do that with a classical contract between our NSO and the universities or the private sector. And I also mentioned at the beginning the question of the governance, and having the right contract with these stakeholders will be one of the issue that we have to solve. To solve. I can answer that this way. And the criteria that we use, the criteria I mentioned. So at the beginning, we will focus on the statistical purposes. The criteria are really the innovation. So we started 5 pilot projects, and the key criteria, and I can make that available if you want on the platform of the UN Global Working Group. We define a little bit more than 20 criteria in order to select the project that we want to focus on. The key idea is really to gain experiences and create innovation with current data or with big data. That's the key idea, is not to choose or to pick up the most funny project that you can find. We will apply very scientific criteria. So how I can give some example of that. Do we have the data? Do we need to collect the data? Do we know the data, or is that something complete new for us? The other things is which kind of method we will have to apply. That's all, really a lot of criteria. The key idea is really to not to start with something that we don't know at all, but really to try to build up step by step. And we were quite successfully with this approach and our pilot project, and now we will offer that to the other federal agency. So the key idea is not to have the funniest project in the federal administration. We are not interested to that, but it's really to be able to show to the rest of the federal agencies that we have the competence to deal with these methods. That's but if you want, I can upload the criteria that we use, our scientific criteria, not marketing criteria. Yeah.
Thank you. Thank you, Bertrand. Thank you for the presentation, for this exciting work going forward. And certainly, I think, as you also at the last part, what you say, there is, I think, on this work of these criteria that you use, I think that's something that we can also take up and discuss more broadly at the Global Working Group, because of the other data science campuses and so forth having the same kind of issues about what they will take on. So I think that's a part of the work going forward. Final word, I hope that when the World Data Forum next year in October 2021 will be physically, hopefully, in Bern, that we can have a session and then present some of the early work of your data center. I really hope that we can do that. Look forward to that.
Okay.
Okay.
Thank you very much.
Thank you very much, Bertrand, for this presentation. Now we go over to the second part of the of this webinar, which is around the use of the AIS data from the perspective of the hackathon, which was recently held, organized by my colleagues under the UN Global Working Group of big data, of specifically the task team working on this AIS data. There was a hackathon was done very early in September. We had 17 teams working on with the AIS data, which we have on the UN Global Platform. So it was these 17 teams were got 3 days to work with those data to come up with some innovative solutions in relation to climate actions and SDGs, if possible. We out of those teams, we finally selected two, the number 1 and 2, which will make a presentation here. And the team that won this hackathon is called Blue Carbon. It's a team led by Thomas de Wilde, who I will give the word to very soon. The team otherwise has Denis Grabash, Tomi Kalava, Alexandra Kapustina, Gennady Abrastov, and Farid Rakhmatulin. So a very international team. I think they're mostly in the Nordic countries. The more further description of the team is available on our website. Please go ahead there. What the Blue Carbon team wanted to do is develop a model for attributing vessel CO2 emissions to locations where they occurred, based on the vessel AIS locations. And they made an interactive application for that. And I will now give the word to Thomas to further introduce and show what solutions they come up with. Thomas, the floor is to you.
Hello, and thank you, Ronald. Much appreciated. Indeed, my name is Thomas de Wilde, and together with, as Ronald mentioned, Denis Grabash, Tomi Kalava, Alexandra Kapustina, Gennady Opratsov, and Farid Rakhmatulin, we are Blue Carbon. And thank you for having us. Now, when we're talking about data innovation and data science, it's almost become a platitude in a way, saying, oh, big data, you know, so much value to be had there. And of course, we would agree with that, but we prefer to show you what you can do with data instead of just talking about it. And just two notes that I'd like to kind of highlight as well is that when we saw the opportunity of competing in this United Nations AIS Hackathon, we immediately jumped at it because it really goes to the core of what we do, not only in our daily work, but also what the company stands for. Wärtsilä, as its purpose, has to enable sustainable societies with smart technology. And so without further ado, let's demonstrate exactly what we came up with and how we use big data and create digestible information. When first arriving on the platform, we're presented with a global view of shipping emissions. In the top left-hand side corner, we have those emissions broken down further. And when we highlight specific tiles, in the top right-hand side corner, respective emission data is displayed there. Now, at this level of zoom, we can see that there are some interesting areas around the world with high emissions. But what if we're interested in something more specific? Well, we can zoom in, press refresh, and now these tiles have been broken down into their granular versions, allowing us to pinpoint where the emissions are, as well as identify shipping lanes and busy ports. Now, as a researcher, you might be interested in the interaction between emissions, and more specifically, you might be recording local emissions from biogenic or land sources and wanting to subtract the global shipping emission data, the background noise, generated by shipping. So if we take the Azores as an example and we go there on the map, we can actually upload a GeoJSON file allowing us to draw a polygon or a certain shape around this area, allowing us to quickly identify tiles that intersect with this area in order for us to then subtract this global shipping emission data from whatever local recordings we might be making. Additionally, we've also added the exclusive economic zones. And if we were to, for instance, take the Italian one, it'll automatically take us to that location on the map, as well as generate the granular tiles of emission data. Right, so that's what we created for the hackathon. Now, you know, big data or visualizing data is one piece, right? So you create data and then you need to create a front end to show it. But a front end is nothing without data, and a data is nothing without being able to visualize it. So in order to show you how we exactly achieved that, I'd like to introduce Farid Rahmatulin, our front end developer, who will tell us a little bit more about how he created the front end of our platform.
Yeah, thank you, Thomas. Hello to everyone. So a rough mockup had been created by the team, which was up to me to create. So this is what I did. First step was to choose the stack. I stopped at classical HTML, Bulma framework for CSS, and Leaflet JavaScript framework for interaction with the map. The main challenge was to show aggregated data on the global map relatively fast. To achieve that, two methods was implemented. First is caching heavy requests on the backend that allowed to load global map and the most popular exclusive relatively quickly. Second is using different granularity of data, meaning that on the different zoom level, different tile size is selected. So in the future, we are planning to keep working on responsiveness of the front-end page and finalize the API to make it public available. And so now I'm giving the floor to Denis Grebash to talk about data architecture.
Yes, thank you, Farid. So we had three ingredients to our solution, and the first one is this AIS vessel location data. And just for those of you who are not deeply familiar with it, so just assuming looking at the 70,000 largest ships of the world merchant fleet, and if they are transmitting a new position every 5 minutes, then that amounts to 20 million records per day or 7.5 billion records a year. So that's truly big data. But big data on its own is nothing. combine it. You need to give it some context. And there we were happy to see from the EMSA, the European Maritime Safety Agency, the MRV data. MRV is for monitoring, reporting, and verification. And essentially, since 2018, all the ships that are moving around in European waters, they have to report their yearly emissions, and that covers around 10,000 vessels. So that was our baseline for the emissions data set. Further, we used marine regions for the so-called sea borders of the countries, these exclusive economic zones, and all of that you've just seen being used there in the map. The output of our solution is, on the one hand, the data itself, so that's emissions per area and per day, and that can be distributed in a CSV file or by API. And Alexandra and Gennady will show some interesting stuff later. But then on the other hand, we have the map there, and that's much more than approachable for all the rest. So big data, to make big data actionable, you actually need to make it small. And to do that, we divided the world in a million tiles. You see 5 of them, and you see one vessel there moving back and forth between Finland and Estonia. And in this example, we then reduced the data set from 270 records to 5, so that's 2% of it. And with that running on the UN Global Data Platform, we're able to aggregate a day of AIS data in 40 minutes. And now I hand over to Tomi Kalava, our data science architect from Finland, and he will tell a bit more about how it was done.
Okay, thank you, Dennis. So how we are estimating the emissions? We combined last year's emissions reported by MRV to AIS data for about 10,000 vessels. We took features that would have some explanatory power to the emissions, such as speed, draft, and vessel dimensions, and aggregated those to the same yearly level that we have in emission dataset. Then we fitted a random forest regression model to that data. With the model and tile vessel aggregations that Dennis mentioned, we are able to calculate the emissions for each of these areas for each day. And I'd say this is quite handy approach, but it comes with its limitations. First of all, we noticed that the estimations for individual vessels are usually not super accurate. However, over a bigger number of vessels, it performs quite well. And for our case, that is fine, since we are looking more at areas with a lot of vessels and their combined emissions. But the problem occurs in areas where the training data doesn't quite match with the AIS records. For example, if an area is smaller vessels, it might not give accurate results, since we don't have small vessels in the training data, as seen from this distribution of vessel lengths. And also for the vessels that are staying still, the emissions are typically overestimated. But both of these limitations we face in port areas and rivers mainly. And at this point, we addressed these limitations with certain simple rules and assumptions in the process. For example, assuming that ships that are not moving are not producing emissions. And there are of course still room for improvement in many fronts, and also factors we didn't have time to address at all yet, like accelerations of vessels. And finally, when we talk about validating the performance, typical way of measuring the performance of a machine learning model was not enough in this case for various reasons. And that's why Alexandra Kapustina, also a data scientist, made some additional validation there.
Yes, thank you, Tommy. Indeed, we wanted to have some independent model, and we went to IMO greenhouse gases official report, official study, and got a physical model of emissions. And based on AIS data, and we used some average characteristics per ship type and size, we used this model to validate our model. Of course, using particular characteristics of ships would give us more accuracy, but still it was like a comparison. Also, we tracked the approaches IMO organization used to allocate emissions before. Firstly, started from vessel-based when we tracked emissions by vessels when they switch to voyage-based, taking into account ports of departure and arrival. And here our special-based approach could be seen like a next step, like an extension of these methodologies. Also, we wanted to give an example of local usage of our tool. We used an area around Rotterdam port, and using our tool, we calculated the spatial distribution of emissions and also some coefficients like emissions per distance, ship travels in this style, and we wanted to show how comparing with coefficients and values we could maybe spot some places which needed to be investigated for maybe further traffic optimization or some policies to be used. And also we could analyze it and get some port emissions. And Gennady Obraztsov, my colleague, could add us more information, a data scientist.
Thank you, Alexandra. First, I help Alexandra calculate the other emissions, sulfur and nitrogen oxides. Why are these emissions selected? NOx has a high biological activity and leads to a decrease in respiratory function, and SO2 affects the rate of photosynthesis, especially in conifers. I found data on the concentration of nitrogen and sulfur oxides. On the slide, you can see mass concentration of nitrogen in Rotterdam area. This data is freely available on Copernicus site. So then I visualized our model's results in Rotterdam area to check it qualitative. Copernicus data is on the left picture and our model's result on the right. I overlaid the average wind speed to check that the distribution of nitrogen oxide concentration was not influenced by land sources. So in the future, with more resources, we could do a diffusion analysis, also calculate perixical nitrites and aerosols, and maybe overlay air quality data in coastal cities, especially in emission control areas, and overlay wind data on the map. Yeah.
Thank you, Gennady. And that's now brought us to the end of our presentation. Before I open it up to questions and answers, I did want to specifically thank the United Nations, the Working Group, Global Data Platform, everyone involved in hosting this competition. It was great for us, honestly, to be able to compete against such esteemed research institutions and groups who clearly have great competence in this area. We like to think as Wärtsilä that we have some of those competencies in-house as well. So it was nice to be able to showcase that. But it's also nice to actually address kind of the elephant in the room. And that is emissions, right, and their impact on climate change. We chose, because that was one of the two options to choose from in the competition, the Sustainable Development Goal of climate change. And we want to lead that discussion. We want to increase transparency. We want to increase availability of data related to emissions so that you can actually have an informed decision about it or an informed discussion. And we wouldn't want to stop there either, because we believe there's a bigger picture here, right? It's not only the difference between man-made and biogenic emissions, but also then looking at land-based emissions or shipping emissions like we have here. And so putting that all together in one complete holistic overview, it is our belief that would not only increase transparency, but also allow policy making and decision making with a clear-headed view on the facts. So we look forward to this data being made available, whether it's on the United Nations platform or on a Wärtsilä platform. We hope that some of you perhaps might even be interested in seeing the kind of the platform or its data that sits behind it. That's only going to strengthen the point of making this available to researchers and policymakers. So thanks again for your attention. And if you do have any questions, please shoot now.
Thank you, Thomas. Yes, this is a really impressive presentation from your whole team, all of them involved in this short period of time of the hackathon. It was truly impressive what you have achieved. Also like it that you added in a number of additional data sources to mix it up with the AIS data to get more results. I think that was truly Great. Also, that's also, of course, that you won this hackathon. It really, you really made that point very clear why you were chosen in this. Yes. I will open it up for discussion. I want to first of all also on the last point, we certainly would like to. And I can tell you that work with your team further on this going forward. I hope that this is the start of things. And also very happy to see that the global platform was being used for this and show that this is a kind of a collaborative environment where we can produce a very good results in data innovation. I open the floor here. Would like to see maybe a show of hands for those who want to pose a question on this presentation. Because I see a question in the chat. Yeah, I have some.
Thank you, Max. I do see some. Yes, Gabriel is raising his hand. Gabriel, okay, if you want.
Yeah.
Absolutely. Thank you, Thomas, for such a great presentation. Once again, congratulations on having the first prize. Certainly, you do have like a very detailed project, and we're very glad that we got the chance to see your details. Going into specifics, you guys have like a granular tile description. Just as a reference, what's the size of that tile in terms of arc seconds? You got that information with you?
Yes, well, actually, it's not in arc seconds, so the mileage varies, right? Depending right, yeah, on where in the world. But Dennis perhaps can give us a bit more information about what the typical tile size is for the various zoom levels. And you're muted, Dennis, in case you'd be talking.
Thank you. Yes. Beginner's mistake. Yeah. So it's actually related to the Google Maps or OpenStreetMap zoom levels. We chose zoom level 10, so that's 1 million tiles. And depending on the size, it's I think if I recall correctly, like around Singapore, so around the equator, it's 40 kilometers the side of one of these squares, and then in the Baltic Sea, it's around 20 kilometers. So we try to keep the standards there, what are used by these popular mapping platforms for further compatibility.
Thank you. Any further question, Ivo?
Yes, let me also congratulate the team. It's really very nice to see how this has come together in such a short period. So congratulations with that, the team from Wärtsilä. What I was thinking, maybe Ronald, also in the way forward on this, as we develop dashboards on this at the UN web environment, is this information that we could release experimentally on dashboards for the world to actually start using? I don't know how far it is, but would there be a possibility to work in the next step to make this more sort of permanently available in a fixture of our new dashboards that we're trying to shape? And that's a question to probably Thomas, whether that would be something that you would be like to think about with your team going forward.
Yeah, thank you for the question and your kind remark as well, Ivo. And I will actually add on to your question, Andrea's question in chat about the time period covered by our analysis. And that is, yes, indeed, we want to make this data available. We would actually like to go one step further, because for the hackathon, as Ronald mentioned, we only had a few days. We had to use a confined data set, right, of only covering about a week's worth of AIS data. So what we would like to do is we would like to improve the solution further to ingest data on a daily basis, so that it's a live, self-updating, real-time type of platform, and then have it somewhere hosted indeed for anyone to use at any given time, both from a visual point of view, but also from a data export point of view, to get the underlying data.
Thank you.
Yeah,
Looking
thanks, Thomas.
forward.
Can I add on? Can I add on to this just to on the point, like how much support do you get internally from Wärtsilä to work on this more with in collaboration sector?
Well, it's a great question, and Marky in chat also asks about how do we know each other. So we're colleagues, and our passion for everything data is the reason why we know each other. And then of course we have worked collaboratively in the past on various internal projects. I will say that our participation in the hackathon was really us just coming together. Let's go for it, and we made sure that we checked it with the powers that be, that we wouldn't upset anyone. But it was very much kind of an employee-driven project, and it's, to be honest, one of the great things of working for Wärtsilä. There's plenty of room for innovation, and you can get the necessary support or buy-in to do these type of things. Now, of course, the next step is, how do we formalize this effort? How do we make it more of a, nice, well formally kind of organized collaboration between Wärtsilä and United Nations, opposed to just a bunch of employees taking part in a hackathon. I guess that's the small challenge. I see there's perhaps another raised hand, or
I did not see a hand. Is there a hand?
Esperanza, perhaps.
Esperanza. Okay. Yeah. Yes, please go ahead, Esperanza.
Yes, thank you very much. This is really indeed a very excellent presentation and work that you've done. I have two questions basically. One is on the model that you were presenting. I think the lady that presented said that, in terms of the model validation, you have to find an alternative one, because the one that you got is not necessarily the one that you wanted to have in the model. So my question is, in terms of identifying the best model, what was the criteria? And then related to the criteria of the hackathon, was it used to identify the winner? I mean, the model validation itself. And so the second question is related to the way forward of this output or this outcome of this hackathon. Because at some point, I think somebody already also mentioned about how this data could be linked to something more like, I would say, timely, and in terms of using this data for for example, addressing SDG related issues, so that a more timely data could be used for outputs, and countries or whoever could benefit from these outcomes can easily see the data. So for example, you're using Spark. If you have Spark streaming, could be linked to this with the original data set, or whoever is owning the data set, if this is nothing sensitive related to that.
Yeah, thank you for the questions. I'll park the one related to did we win thanks to our the way that we validated our model to our dear friends from the jury, I guess, that are present here, and I'll touch on your future question first, then pass it on to Alexandra and Tommy to talk about the model. And I see there's another question in chat as well related to model, so maybe Alexandra, Tommy, you can already kind of gather your thoughts about that one. In terms of the future, you're absolutely right, and the Spark platform as well, to be able to, like we said, do the improvement that it ingests data automatically on a daily basis. Dennis was talking about that this would only really take about 40 minutes. So, it could be a scheduled job somewhere during the night, would keep this solution current. And because it's holistic, because it's global, you do bypass some of the issues that you otherwise see with locally recorded emissions, for instance, right? Because there's quite a bit of difference between from country-specific measurements. But again, yeah, we're happy to have it there, but I guess the UN and maybe the powers that be in Wärtsilä need to kind of pull the trigger. But we're definitely pushing to see that be a reality. Now, Alexandra, do you want to talk about the model validation and then maybe pass it to Tommy about the actual model?
Yeah, I could add maybe some details, because our model for validation, IMO, based on IMO methodology, is not so, how to say, doesn't perform for all types of vessels. It's just for some typical more popular types, and we used average characteristics there because we didn't know particular like fuel type or something like this. It could improve it, and so we checked it for the most typical types like cargo ships and so on. And our ML model was validated on these cases, and we used it for all other vessels because it's more universal. Maybe Tommy will add something.
Yeah, okay, thanks. So the algorithm which we used was random forest regression, and that was like the first out of the pocket. We didn't spend that much time testing different algorithms because we had so much stuff to do also in the data flows and pipelines and the backend work also there. And how does it work is that it's kind of model gives us the estimation what the yearly emissions would be if the vessel would have those parameters that we get from the AIS record. And those are like the model expects like average speeds and stuff like that. So it doesn't perform well in low speeds or very high speeds or when vessel is accelerating. And also the the vessels in the training data are bigger vessels. So that kind of limitations we have, and we have to validate with different methods then that we are producing somewhat right results. So there's definitely room for improvement in the accuracy, but also we have ideas how to do that.
Yeah, and on that note, we have a lot of internal data, of course, as an engine supplier, but we chose not to use any internal data because, in the spirit of the competition, we only wanted to use publicly available data. As much as the temptation was large to double check, with our internal data whether our emission estimations were correct, but that's just we wanted to play it, fair play. So with the improvements that we have in mind, maybe that could be an opportunity as well in terms of improving the model with measurements that we as a company make. Now, I don't want to take too much time away from the next team. I see that we have two more questions. Perhaps let's just quickly do those two and then wrap it up. Gabriel Gomez, if you want to ask your question.
Hi, thank you very much. Actually, it's not so much a question, it's more a kind of general comment. I wanted to mention that this hackathon was actually financed through a development account, so a capacity building program of the United Nations. And I remember the first time when Marky and Jonathan came to me and we came up with maybe using a little bit of the money for a hackathon. People around here thought that we were a bit crazy. But just to reassure you, and I liked very much when you said we speak a lot about big data, now let's try to do something with that. I think that this is an excellent example, very much a success story of this development account, this hackathon. And in the next development account that we're preparing at the moment, drafting the concept note, we explicitly mention that we will keep money on the side for a few hackathons. So we will continue to work with that also in the future. And I wanted, of course, to congratulate all my colleagues, also the winners, but also all the other ones that participated in this hackathon. I think it's really something that is fantastic, and I will use that to illustrate, this success as a success stories of this development account. Thank you very much, everybody.
Couldn't agree more, Gabriel. Thank you. Christophe, last but not least.
Yes, I will be very, very short. I have just one question, and it is also a remark about the training data set. Because the question could be, and you won't probably have time to answer, the trade-off between having a more detailed training data set where you have also the sea, the weather forecast, the wind, or whatever, or a more accurate, more maybe costly model. And in fact, the remark is that I believe that the next gold mine is not in the big data themselves, but in validated training data sets. Because with very good, accurate training data set, even simple model could perform very well. So the remark is, should we build a sort of Fort Knox of training data set that are really, really with very good data? Of course, it's just an idea.
I'm sure that Tommy and Alexandra and our other data scientists in the call here would jump the opportunity, Christophe. Absolutely. Thank you.
Thank you all very much. Again, Thomas and team, I think was a great job. Congratulations with that. Congratulations also again now with this presentation, and certainly we will want to continue collaborating with your team, and we'll follow up after the webinar. I want to go now to the next presentation. It is by the Data Caliber Group. That's led by Gabriel Fuentes. Other members of the group are Rebecca Caceres, Hussein Ashri, Javier Sanchez Galan, and Javier Diaz. Again, information about the team is also on our website. And I will now give the floor to Gabriel to indicate the work that they have been doing with their team. Gabriel, please, the floor is yours.
Thank you. Okay, so just give me a thumbs up if you can see my screen right now. It's always good to...
Yes, we see your screen, Gabriel. We see your screen. Go ahead.
Very nice, very nice. Thank you, Ronald, for your nice introduction. It's always a challenge to present just after such a great presentation as given by Thomas and his team. Well, I got to say that we're very happy to be able to share with a larger audience the results on the hackathon. Hello, everyone. My name is Gabriel Fuentes. I'm a PhD student at the Norwegian School of Economics and proud speaker for the Data Caliber Group. We have some of our team members live as well, and they will be available to answer questions afterwards. Some others have some obligations regarding classes, and there might be working time as well in some regions. So, having said so, we're the runner-up team for the 2020 AS Hackathon, and today I am presenting the methodology, results, and framework of a method aligned to attend some of the global issues faced by shipping. So without further ado, this is the Panama Canal and Suez Canal transit information from AIS, and I add a bit of something, and as this become already a building block towards green corridors implementation. In this presentation, I'm covering the motivation behind our model, the methodology, some empirical results, which we extend to a framework where some of us are now interested to work with, and I'm closing with some conclusions. One of our big takeaways from this competition was to work under time pressure with people that never worked together before at 3 different continents, and people with different backgrounds. More importantly, we selected special profiles for the goals we were aiming to achieve. So we certainly achieved those goals by gathering in a team, including Mr. Hussein Ashri from Egypt and the Suez Canal Authority. Myself at Norway, at the Norwegian School of Economics. And 3 Panamanians, Javier Sanchez Galan from the Technological University of Panama. Rebecca Cáceres, who is a specialist in maritime affairs in Panama. And Javier Diaz, a professor at the International Maritime University of Panama. So, and I also kept this one because together with our team members, I do need to recognize this, and I'm sure these names are familiar. I would like to appreciate you guys, Jonathan, James, Joel, Sean, Habibur. You guys did an outstanding job assisting all participants, and you were like upfront in all the needs that at least our team had. Thank you. So now into our motivations. First of all, it is perhaps already stated, but we will reinforce this statement with the importance of both canals, the Panama Canal and the Suez Canal, to global trade. So in here, 6% and 13% of world trade by volume passes. And that gave us a hint that this might be an opportunity to signal global trade changes in a reduced territory. Importantly, as this is a reduced space, the spatial query is significantly reduced as well. And this is particularly important in big data environment. So we identify that there exist very few options related to micro-level detail of canal operations, particularly those available to researchers. And having that most of us on our teams are academics, we really value the fact that we could generate data for further research. By building this information, we're helping in the efforts of optimizing operations as well from both canals, aiming to help in the boost of trade, increasing income and employment, which are important factors of the economic growth, not only of the countries hosting the canal, but also of the nodes connected by those canals, a goal identified in the Sustainable Development Goal 8 regarding decent work and economic growth. So another challenge that we identify is that of reducing emissions via operative measures, which can be classified under the umbrella of Sustainable Development Goal 13, climate action. Specifically, the measures identified by the IMO GIA just-in-time arrival guidelines recently released. One of the important factors for the implementation is the continuous streaming of vessel information, but under specific requirements. And we will explain a bit additional on that. So we identify that having a reliable method of data generation, the next step is to build an optimization machinery that can schedule transit based on environmental and efficiency considerations. You could call them constraints. And we will touch upon that on a couple of slides from here. Finally, this exercise helped in testing how well competitors, and I quote that, can structure plans to attend global problems and issue service under Sustainable Development Goal 17, Partnership for Goals. Now into the methodology. With the use of this diagram, I will try to explain the methodology as follows. From the AIS supplier, namely the UN Global Platform, we extract only the position of vessels within a polygon box. So we make a special join query to do so, and that reduces the amount of information that we need to handle afterwards through machine learning methods. So the box has two ways, the information we gather. First, we use it to train our random forest model that forecasts the vessel movement from including wind information from the Copernicus project and tide information from Admiralty tide tables. So the deal with this random forest is that it does connects to two Docker containers that we built for this occasion that also absorbs information from the spatial query. And the machinery here works via dbScan, the density-based spatial clustering application with noise, which is a machine learning unsupervised method, very well documented in literature in terms of recognizing vessel movements. So once the machinery does its job, the results are stored into a new database, which contains the algorithms which is used for the analysis, including vessel specifications, which in our case were supplied from the Clarkson World Fleet Register. So the central algorithm, what we can call like the core of the whole business in here, is that it recognizes sequences via spatial filtering first with the polygons that we created for these occasions, very detailed polygons. Then it recognizes anchoring patterns via the machine learning unsupervised method dbScan, with the parameters being supplied by the machine learning method random forest. So we faced another issue, and was the issue of interpolating missing position and gaps within the sequences, and we did so with the use of Kalman filters that we developed for this occasion as well. So if we now try to see it visually, and this is the example of a single vessel, it will help up clarifying some gaps. So first, the vessel approach and anchoring area, and the anchoring algorithm recognizes the stoppages. So from the start and end of the anchoring sequence, we calculate the waiting time of a vessel before entering the canal. This case in specific is the case of the Suez Canal. So to identify the commencement of a transit, we do so by interpolating a vessel going into a single entry point somewhere here, as we might have vessel approaching the canal from distant anchorage or different anchorage. So we try to make this as fair as possible, calculate it on the same path. So the next information of value is to determine at what time does the vessel exit the canal, and if they had any stop in between, namely stops for ports operations or anchoring inside the Great Bitter Lake, that is an operational stoppage in the Suez Canal. So together with this information dynamics, we are also collecting the draft information of the vessel to help us in measuring changes in trade volume And we will get to that in some next slides. So directly in the case of the Suez Canal and the empirical results, we got in here something like a percentage of 63 to 86% of transit as compared to official statistics. So the graph at the top highlights that relationship. Regarding the waiting and the transit times, the Suez waiting time are confirmed by our Suez Canal specialist, Hussein, who show that this is what they observe in practice, meaning transit times of approximately 11 hours and waiting times of 9 hours in average. Please note the slight variation in the transit time, which is the outcome of control convoy system due to space limitation in the Suez Canal. Moreover, the relationship of waiting times and number of transits can be observed from the upper and bottom graphs comparison. In there, we observe how less transit derives into lower waiting times due to shorter queues. Additionally, the number of transits seems to signal international events affecting global trade. For instance, we observe the behavior of vessels passage following the declaration of the COVID pandemic by the World Health Organization. An important observation also we got from the waiting times at the bottom is that vessels going southbound in a transit, and you could call it backhaul or against the flow of trade, experience a significant reduction in waiting times. So as observed in practice, this has to do with two main reasons, perhaps lower vessels waiting in one way or the other, and the other one, a forced just-in-time arrival as fewer anchoring spots are available north of the Suez Canal, namely Port Said anchorage. If we measure related emissions, I am positive that we will observe that this force just in time leads to reduced emission level based on vessel speed. And this points us towards the potential impact canal scheduling can have in terms of emissions reduction. So in here, we observe a comparison of draft ratio, which we use to proxy the level of cargo carried by a vessel compared to its total capacity, namely the summer draft or the tropical freshwater draft in the case of the Panama Canal. From the draft ratio measuring relative volume carried by vessel, we can observe what looks like a strong relationship with related information about exports on some commodities controlling this type of routes. For instance, at the bottom left, you can see the exports on Saudi Arabia oil export, which are signaled by the changes in draft of oil tankers crossing the Suez Canal. It's important to note that this database, or at least the blue graph at the bottom, is sourced from the working group. So we could make a comparison with our results and we see how they relate together. Now into the Panama Canal case, we conducted a similar analysis and find out our algorithm has a performance of 60 to 83%. We also observe fluctuations of number of transits and their impact in waiting times. So some downturns are observed just following World Health Organization declaring the pandemic, and afterwards well-expected market transport behavior then. So in a similar fashion, we compare the draft ratio of vessels passing the canal, and we observe how sensitive the value are when China comes into play, and that's on the bottom left graph. So we can observe less volatility on the canal transits, the Panama Canal transit, when China comes out of the game, probably at times of Chinese New Year closure. Additionally, having information of exports provide with a lag on what to expect in the canal after. You can see here, and you may have something like 1 or 2 weeks lag of what the movement of cargo would be at the Panama Canal. That is particularly important in terms of planning their working force. An additional curious case in here is the Diamond Princess quarantine declared by in Japan. The cruise ship sector abruptly declined the transit just after the lockdown in Japan. So let's remember the shape of the Suez distribution, and to help us in visualizing that, I will just put it in here. And we observe how larger the variance is at the Panama Canal. It is important to note that the booking system in both canal differs, in the Panama Canal differs from that of the Suez Canal, and the difference seems to be reflected in their distributions. We have the hypothesis, and yet to be tested, and it brings a research question, that the booking system seems to open a door to speculation on the ship owner sides, as they might rush to wait a premium spot to transit in the Panama Canal, causing additional emissions. In addition, this distribution encourages us to go deeper in further research, namely using the waiting time distribution as a measurement of emission efficiency, and using all the distributions generated from the algorithms as fit for optimization models, namely stochastic programming models. That under the assumption that vessels with shorter times have a better planning, perhaps prefer to pay premiums for just-in-time arrivals, and have planned the proper speed and reduce emissions on their way, which introduces us to the following slide. The just-in-time framework for emissions reduction using information generated by our Hackathon model. So we understand that this can work as follows. First of all, we will follow the just-in-time arrival guide that was recently launched. In there, a set of implementation recommendations and barriers are highlighted. Important barriers being the exchange of information between stakeholders, and this has to be both technically and commercially sound. But our question is the following. What if stakeholders involved are the vessel and the port, meaning no customs, no health, migration, pilot private supplier, tug private supplier, etc. And the only information needed is to have prospect vessels monitored by AIS information. Well, we do believe that this is possible starting from the Panama Canal case. They have the advantage that they manage all their auxiliary services. They are also part of a single window platform where if the vessel is just meant to pass the canal, they only need to be cleared by a single visitor in a couple of minutes, being all documentation in order, of course. Additionally, with their booking system, they already have just-in-time slots on their demand, meaning that people has to pay for it, the ship owner has to pay for it. However, we propose to take one of those slots, at least on an experimental stage, and transform it into what we call the green slots. That is, free of charge premium slots assigned under robust optimization models where the most convenient vessel operatively can be assigned based on just-in-time and monitoring of distance from the canal, weather routing, and conditions. So the assignments could acknowledge both emissions and fresh water levels from reservoirs at the lakes and the canal in order to save water via combined lockages on feasible vessel combination. It's important to note the efforts of the Panama Canal nowadays in terms of saving water and the new fees they have charged on fresh water, pumping fresh water in vessels in there. So the vessel times as supplied by our algorithms serves as measurement of implementation success. That is, lower waiting times will signal better voyage and speed planning and could be also a measurement of policy implementation. Additionally, ship owners can benefit in terms of voyage planning and fuel management. So a natural extension of the former, I'm closing with this slide, is that it could be followed for what we call the green corridors, and that's being an extension of the canal cooperation with other ports meant to be connected by the canal and the inclusion of their port operations real-time information as part of the scheduling into the canal and into calling those new ports. So the hackathon, if you check out on stage 1, could be considered as a good intro to a bigger plan that is under discussion as we speak. So the pieces, at least in paper, seems to fit properly into the extended framework. So more on that, we are happy to share that our initial cooperation within the hackathon with people that never worked together before is transforming into something tangible. We just get the confirmation of the Maritime Technical Cooperation Center Latin America, one of those centers built by the IMO in terms of emissions control in different regions, which is hosted in Panama, and they agreed to establish a real-time monitoring center for emissions and trade information with information collected from their privileged position at both entrances of the Panama Canal. As you can observe on stage 2, we could call this the MTCC port. More importantly, this will be fed with the algorithms that's generated from the hackathon. So in general, the idea is to have a real-time monitoring center follow on stage 3 by an optimization real-time structure from the monitoring and an implementation in ways to become a just-in-time control center or with very few to add in order to become one. I guess this is a good time to express that we're open for cooperation, perhaps on the side of blue carbon for emissions monitoring. If you guys are interested, we're really open to have further conversations on that. Our center, certainly the UN Global platform for cloud infrastructure, if that's something you might be interested in. So further extension and cooperation of terminals will lead to the creation of the green corridors. We can call that stage 4 and stage 5. Easy when we consider that technically, but challenging in terms that we need to align all the necessary stakeholder and their system at the same plan. So within the conclusions, we demonstrated that more granular statistics are achievable by higher frequency AIS positions and feature engineering of the canal operations. This, of course, under well-defined interpolation methods and parameter selection. So from the empirical study, we show how well do they signal changes in global trade health. Statistics built from AIS and a few barriers of implementation affecting just-in-time in the Panama Canal might show how the Panama Canal have an incentive to be among the early implementers of green slots or part of green corridor policies. The methods presented herein could ease the implementation of policies which require continuous and in real-time monitoring. And the most important lessons learned is how from the exchange of information between members of academia, industry, and government from 3 different countries, you could call it 3 different continents, we could design tailor-made solution with all the flavors included to attend global issues. Having said so, I do appreciate very much your attention. If there are any questions, I will be glad to answer them. We are also open to have additional conversation. Here's my email address. I could address you to or transfer you to some of my colleagues in their expertise area, and the slides are present at the website that you see below. Thank you.
Thank you very much, Gabriel. It's a great presentation and also already an extension on this going forward, which I think is very exciting that you see the opportunities to collaborate further and have started some initiatives of moving this forward around the Panama Canal. Again, we will certainly want to work with you on this initiative. Also with our network and the connections that we have, I think we can really bring that forward. So with that said, I would like to ask for questions. I know we're a little bit over time already, but I certainly think we can do a number of questions up to about 10:30. That's the New York time. To raise hand and come up with the first question for Gabriel and his team.
I do believe there's a question on the chat now, Ronald. If we may address that. Yep.
Yeah. If you want to address that, Gabriel, you see the question. Go ahead.
I do. Yes. It's a question from Marky. Thank you, Marky, for your question. And well, his question is like, can this algorithm be applied to inward waterways such as the Mississippi River? Definitely. So the main concern we had at the very beginning was building this, at least streaming this anchoring algorithm, how to recognize a vessel is at anchor. And our approach forward was like, first, making a shortcut by knowing meteorological information and tidal stream information. I do know that in terms of the US, NOAA, for instance, has very well-defined structure and real-time information on tidal streams, on wind and currents, and that certainly could ease the implementation of first the anchoring patterns and secondly the follow-up of the vessels through the Mississippi rivers. So very easy to implement. We just need to have the input, the AIS information. We need to build on on detail the polygons that follows the Mississippi rivers and the ports that are within the lane. And we can certainly build up very nice information based on that.
Thank you, Gabriel. Any other questions? Do I see a hand or a question in the chat? I see Esperanza, you wanted to come in.
Yes, thank you. Excellent presentation and work. I have a question in terms of the choice of the model. I think both of you chose random forest. Was there a criteria? What was the criteria in choosing the model, or did you run other models such as SVM and all other machine learning models? Have you tried them, or you just chose the random forest?
Well, thank you very much, Esperanza, for your question. I don't know if Javier Sanchez Galan is within the audience. Perhaps he could help us in replying. If he's not, yes. I can also reply, but
Oh, yes, yes. I can.
Yes, there he is. Yep.
Yeah, thanks, Esperanza, for the question. Well, to be frank, it was a very challenging task. Basically, we had to clean up the data, and the one thing is that we were predicting the speed. Speed being a continuous variable, then we had to do some type of regressor. In terms of what regressor could work best, we thought right away to use random forest as a regression task, right? We have not tried SVMs or whatever neural networks at the moment. We just went to see how this works, and one good feature of the random forest, probably other team can say that also, is the way that it interprets the data. It gives you a way to see which variables are more important, which variables separate the data best. And so it's a very explainable model that anybody can see. You can see you can see the code in the collaboratory, and you see that it provides a tree, and you say, oh, this doing this decision, and then this decision, and this decision, and then we were able to put the feature importance right there on the right, so you can see which features were more important to build these trees. So then you can say, oh, right away, oh, the course is very important, or the draw-off ratio, or I think in one of the canals was also the tide and some stuff like that. So it's very interpretable. So and one thing, to be frank, in my experience, is SVMs is a very interesting algorithm. It provides amazing results, but it's hard to explain to anyone. It's like a non-linear, way to explain things, but it's not easy to grasp the concept that is how the support vectors are made, or the decisions are made to make the support vectors.
Yeah, if I may add on that, Esperanza, and as Javier outlining pretty well, of importance for us was like critical, because we wanted to see if the model makes sense in terms of operational movement of a vessel at an anchorage. And what we can see here, for instance, that the course is one of the main explanatory variables. However, that was obvious. The second one gave us a nice surprise, and this is the draft ratio. The draft ratio in here could be interpreted at how much of the vessel's surface is exposed to either the wind or the underwater part that is more affected by the tidal stream. So you could have the vessel being affected by the wind, such as the case of the car carriers as when they are anchored, or you have the vessels more affected by the tidal stream as the case of box-shaped vessels such as bulk carriers or oil tankers.
Thank you, Gabriel and Javier, for this additional explanation. Very, very clear. I would like to add, because I don't see a hand up, but I would like to add myself a question more on the outlook forward, as you already indicated, Gabriel. Yes. And my question there is the support that you have from the various parties that would like to be part of this initiative. And I don't know how far you can already say something about this. I know it's new, right? It's you've just started on it, but from your own position where you are now, I think this is the School of Economics in Norway. And then I know that in your group you had members of the Panama Canal Authority, other related parties there, and you mentioned also the regional office of IMO being involved in this. If you could say a little bit more about that, I think that's interesting how that is coming together, Gabriel.
Absolutely, absolutely. This is a project that gives us a lot of at least enthusiasm. I do believe we might have a bit more flexibility than the Varsila group, where academics that pretty much like had a lot of options or flexibility to do things as soon as they contribute to society, right? So in that case, I think that I can give floor to Javier Diaz, that is more involved to this regional center. He's like working hand in hand with them, and he's our liaison there. Javier Diaz, are you there? Perhaps have you finished your classes?
Yes, I'm here. Can you hear me?
Yes, loud and clear. Go ahead.
Yes. Good day, everyone. Thanks, Gabriel, for the floor and for the presentation. It's also very good to be here participating, representing also a Caliber group member winners of the second place. We really like this work and this AIS Big Data Hackathon. We enjoyed it a lot. And I'm from the International Maritime University of Panama, which is the institution hosting the Maritime Technology Cooperation Center for Latin America since late 2017 until 2019. But we decided with the authorization of the IMO to continue with the MDCC, and in this new perspective, we would like to start from January 2021, also including some works on what Gabriel has mentioned, the real-time observations of emissions, and also to have some real-time data management center. It was pretty close to what Dr. Bertrand was talking early at the beginning of the session of the Data Science Competence Center. It's pretty similar what we like to implement in the Maritime Technology Cooperation Center from January 2021, and of course, as academic sector, we have a lot of flexibility to work with the industry and to also to cooperate with the government in public policy making, and also in some decision making regarding the industry, the maritime industry, and also we have close cooperation with the Panama Canal, and open, as Gabriel mentioned, cooperation. We're open for regional cooperation, and also for any international also support and assistance, because this is a great challenge. We like to start from next year, so it's very important. It's like a good platform to also mention this cooperation, as Gabriel just mentioned. Thank you.
Excellent, Javier. Thank you for that for that information. That's useful also for us to going forward, and we will follow up. We will follow up with Gabriel, Javier, and the team. There was some initial discussions already, which we had with the Inter-American Development Bank on a project around the Panama Canal. So we'll like to see how we can combine that effort. And I think the green corridors, the implications on the just-in-time arrival, expanding it also a little bit beyond the Panama Canal, or at least the ways into the Panama Canal. I think that's all very exciting work. I'd like to see how that can be taken forward. So I think we're going to close our webinar at this point. Just two words on what we have seen so far. We saw, Javier just mentioned it, the exciting work starting in at the Federal Statistical Office of Switzerland on a data science competency center as of 1 January 2021, indicating how important data science has become for statistical officers in combining new data sources, not only big data, but also other data, and just having data science methods in improving the work. In a similar sense, then, data science applications, we've seen this from the work that Thomas de Wilde and his group at Wärtsilä have done, and their application that they have made, and we also hope that application becomes more widely available. We will work with them on that. And then this last presentation by Gabriel and his team, also explaining how they use the data science, the AIS data and the global platform to in a very short period of time do very impressive work. All of this is also work that's right in the importance of the 2030 Agenda for Sustainable Development of the United Nations. The applications are in relation to climate action very important and has direct relevance. I also wanted to point that out, and I hope that we are collectively can take this work forward. So with that, I'd like to thank all presenters. Bertrand, Thomas Wilde and his team, Gabrielle and the team, thank you very much. I thought it was very impressive what you've presented here today. We have made a recording of this. We will post the recording so that this can also be shared with those who were not able to join us today. I would like, with that, I would like to close. I thank you all very much, and I'm looking forward, very honestly looking forward to work with you on various projects coming forward. Thank you all very much.